Hello guys, and welcome to our very first episode of Theory Explained. Now, today we're going to be tackling a huge topic today, which will be Newton's laws. But first, I'm going to sit down. Don't worry guys, I won't fall. But why didn't I fall? Now that's the question. To understand this, we have to think of Newton's 3 laws of motion. First law states that an object in motion will stay in motion unless acted by a force. Inversely true, an object at rest will stay at rest unless acted by a force. Now, to demonstrate this, I'm going to have to use an object. This ball will do very nicely to demonstrate that. Now, this ball will continue moving until the force of friction stops the ball from moving. This shows Newton's law very nicely because it's going to show the ball moving until a force acts upon it. So, as you can see, the ball is moving, but then the frictional force causes the ball to stop moving. This law is fundamental to understanding physics. But let us think of our chair dilemma. Now, I was in motion, but then I stopped. This must mean I had a force acted upon me. Well, to understand this even further, I'll have to look at Newton's second law of motion. This states that for every force, it will be equal to its mass times acceleration. In other words, if the forces are unequal, that would suggest an acceleration. If the forces are equal, meaning the force is 0 newtons, that would mean that our forces are equal. Now, let's think of our ball friend. So, in our demonstration, we showed the ball was accelerating. But you would say that it wasn't accelerating, it was slowing down. To that, my friends, I would say that the ball was accelerating, only it was in the negative direction. To keep this simple, we're just going to call it deceleration. Now, the ball was deaccelerating until finally the frictional forces took over and caused the ball to stop. So, this must mean that the ball is at rest. Now, Newton is painting us a better picture of why I am not falling down on the chair. So, the chair must be pushing me just as much as gravity is pushing me down, causing no acceleration. If only we could think of a force that would allow me to be pushed up. Well, let's look onto the next part of his laws, Newton's third law of motion. This states that for every action, there is an equal and opposite reaction. Now, let's think that you got really angry and you punched a wall really hard. Now, your hand is gonna feel like it's on fire. This law states why your hand feels very hurt. Now, we don't suggest anyone to punch any walls because it's gonna hurt like the dickens. But what we do say is all we need is a skateboard. Say you have a skateboard and you push off on a friend. Now that friend is going to be moved backward a little while you go backward yourself. And this shows Newton's third law very well. Let's also think of another scenario. How about a rocket ship? In order for a rocket ship to go upward, we have to have fuel. So it's going to explode off the bottom. That's going to push down. But then the rocket ship goes where? Up. That shows Newton's third law. Now we can kind of think of something that could push us upward from the chair. For this, we're going to introduce the normal force. This is a force that is directly up from a given surface. So, I'm doing a normal force, but there is something much more spectacular going on the bottom of the chair and the bottom of my behind. But we'll save that for another theory explained. However, in this case, as I sit down, there's that normal force pushing me up and a gravity pushing down. But since they're equal, there's no acceleration, so no movement. So I stay sat in my chair and I don't evidently fall down. And that, my friends, is our theory explained. And we'll see you next time. Thank you so much for watching. If you enjoyed the video, press the like button and join us on Team Science by turning on the notifications and subscribe to the channel.